Howdy, folks. Tom Barbalet here. This is a special Biota podcast recording and the first of the Visions of the EvoGrid. As I mentioned in the last Biota Live, Visions of the EvoGrid is designed to allow participants and observers of the EvoGrid to record and discuss their thoughts and ideas with regards to what they would like to see with the EvoGrid in the future. This evening I have the opportunity to talk to Scott Schafer about his own particular visions associated with the EvoGrid. Scott's background obviously is, with regards to seeing the EvoGrid announced initially at a grey thumb, and also kind of continuing and following on with regards to the EvoGrid development through Bruce Damer's talks at the grey thumbs in Silicon Valley, and also obviously through the related Biota mailing lists. But Scott has his own particular vision associated with the EvoGrid, which is why I wanted to bring him in on the first episode to give him an opportunity to talk in greater length about the way he sees the EvoGrid. Now, what use is this for the broader Biota community? Well, the broader Biota community can take each participant in the visions of the EvoGrid and think about their own particular kind of prickly problems or things that they're posing into the EvoGrid discussion. And also there may be things that are never actually used in the final EvoGrid that are still beneficial to the broader community. This may motivate new kinds of simulations. This may change the way existing simulations are developed. So I thought it would be an opportunity, in fact a wonderful opportunity for the Biota community to get a sense of the number of different ways that the EvoGrid can go, and also the kind of problems which face people who are developing projects like the EvoGrid, or really artificial life in a kind of broad context. So, as I said, this evening I have the privilege of talking to Scott Schafer with regards to his own particular visions of the EvoGrid, and that is going to be the show this evening. Hello, Scott.
Hi, Tom.
Good to talk to you.
Likewise.
So, I've given some introduction that I pre-recorded, but the idea with regards to the visions of the EvoGrid project is getting a wide variety of people who have seen the EvoGrid at various stages to kind of talk about their own views about the kind of prickly problems and their own particular views with regards to the directions that the EvoGrid could take. So, once you've been on Biota Live, it's probably beneficial to give some introduction to who you are, what you do, and how you first heard about the EvoGrid.
Sure. So my name is Scott Schafer. I've been a professional software developer for about 2 decades now, and a bit of an artificial life hobbyist. So basically my first introduction, I'm not sure how I got turned on to the Grey Thumb group, but my introduction to the EvoGrid project was through that. So I've been involved very kind of tangentially, more as an observer than as a real participant.
So can you describe the Grey Thumb meeting where Bruce first introduced the EvoGrid, and perhaps some background to your own thinking from that initial introduction about the potential and the directions that you wanted to see the EvoGrid go?
Sure. Well, I think, I'm not sure exactly when the first time Bruce presented it. For me, it's a little run together at this point. But as I remember, the sort of initial vision was, as I understood it, was that it would be a way to network existing artificial life simulations, and so that they could communicate and co-evolve together, and to avoid a kind of code fossilization, where Bruce had talked about projects like the Carl Sims simulation, for example, which no longer runs on any systems that I know of. So that was my understanding of what the original vision was, and then it seemed to change a bit into split into 2 projects, one being the broad and one being the deep. In which the deep was more of an artificial chemistry simulation, at least as I understand it. And at that point, I can talk a little bit about kind of what drew me to the concept, which is, I think, a little different compared to where it seems to be headed.
Certainly.
Yeah. Okay, so what interested me about the EvoGrid idea was primarily, so I've cooked up a few different simulations, all of which I feel are sort of a prelude. I'm hoping to make something a little grander than what I've made in the past. But one frustration that I had was that my real interest, I think, is it's less so the kind of emergence of life that seems to be where EvoGrid Deep is headed, as an attempt to kind of simulate and model life emerging from an artificial chemistry. What I'm interested in more is emerging behaviors, and I saw the EvoGrid as an opportunity to present a simulation that I could make with a wide range of environments for the simulated creatures to evolve within. So that was what sort of drew me to it initially. Does that make sense, Tom?
Certainly. And in terms of, your own simulation, to give some background to the kind of contemporary, split of the projects, what you're describing as the EvoGrid Broad was launched last week as Biota Eve, and ironically, the whole legacy associated with Biota Eve and the EvoGrid Broad dates back to the late 90s with the Biota 3 conference, and there was a room of probably about 40 or so simulators, including Jeffrey Ventrella, Gerald de Jong. I don't think Carl Sims was there, but certainly Tom Ray was there. There were a wide variety of people who kind of straddle the kind of very classical kind of late 80s artificial life simulation through the early 90s through to, folks who still participate in Biota Live today. And they had a whiteboard up where they were drawing out what they called Biota World, which was a series of ideas about, as you say, getting these simulations into communicating. And Gerald de Jong raised his hand at one point and said the way to do this is through XML, and to have some XML communication between all these simulations. So really the idea of the XML phenotype, which drives Biota Eve, it dates back to the late 90s, in fact to Gerald de Jong specifically, with regards to this idea of Biota World. And what's particularly fascinating about Biota World is there's a section which I actually put out in the Biota podcast feed where all the participants raise their hands, or not all of them, but probably 90% of the participants raise their hands with regards to the question who or how, is this required for your future artificial life development? Do you, have some commitment to this vision moving forward? And like I say, about 90% of the participants raised their hands. So if we move through to about 2004, we have the Biota at Home project, which again had very similar principles about, as you say, getting these simulations communicating together. I think it was more to do with a kind of programmatic interface, but also obviously some XML communication. So the legacy associated with these ideas of the simulators talking and possibly having underlying units, energy, space, time, these kind of things, really dates back to the late 90s. But what interested me with the EvoGrid from your discussion is that when Bruce first introduced it, almost as a kind of reflexive pattern, he moved back to that, Biota World vision as a means of bringing together the community. And in terms of your own simulation, you've gotten involved with Biota Eve, in the past week since it's been launched. Can you talk a little bit about what you'd like to see out of Biota Eve specifically?
Sure. And am I correct in thinking that Biota Eve is the new name for what was EvoGrid Broad?
Yes. I think okay. The nature of the rebranding was just the kind of historical legacy associated with Biota projects already doing what the EvoGrid Broad was supposed to do, and also, as you've acknowledged, the general level of confusion about what the EvoGrid is at any given time, which will make these visions recordings particularly interesting, I'm sure, as well. So, in that context, please talk a little bit more about what you want to see about Biota Eve.
Okay. My original understanding of what the EvoGrid Broad was going to be was that it was going to kind of enable very, very different types of simulations to network and to talk to each other. So, the kind of core wars simulations where there might not be any kind of recognizable physics. And there'd be constraints within the environment, but it wouldn't necessarily translate into the real world. But those would be able to network with simulations that simulated real world physics or chemistry. The sense I've gotten from reading the threads is that there's been a move towards kind of creating a common physics in all these simulations. So for example, a common, an agreed upon passage of time and attributes and so on. Would you say that's correct?
Well, I mean, the fact that there are units in the physical world doesn't eliminate the fact that, you can have bacteria, humans, and elephants. I mean, my sense is that units don't presuppose the resolution of the simulation that you're going to take. And in particular, with regards to physics, you touch on something that's very interesting because two simulations can have a completely different definition of what energy is in that context. And similarly, space and time. I mean, I think the idea originally with Biotree was that there just needed to be visual representations between the simulations, with the view that if you could put, for example, a Darwin at home form into Brevet, then Brevet could accept either representing the Darwin at home form as a blob or actually the geometric representation of the Darwin at home form, or a wide variety of things in between. And obviously XML and all these kind of the ability to accept a certain level of detail through XML and then ignore everything else was, I think, something that certainly resounded with a few simulators in particular. The interesting point posed by, as you say, the kind of historical legacy of the EvoGrid discussion is still the potential for, as you say, core wars to interact with Fram sticks, to interact with gene pool, and whether these simulations can have any degree of commonality. I mean, if you don't take things like energy and space and time, how do you see these simulations actually communicating, Scott?
To be honest, I'm not necessarily sure I see the value of them communicating, particularly if the communication is going to be on such kind of a lowest common denominator level, where it's kind of these recognized concepts that different simulations can interpret different ways, but they're pretty high level, like energy or whatnot. To me that's interesting, but it seems a little limited. So for example, if you kind of reduce the idea that a creature has energy and can prey upon other creatures, and you reduce it to that level of abstraction, then I'm not sure if you're going to get interesting emergent behaviors from that.
So the idea of Biotree specifically relates to a continuum and also a lot of discussion. So as we describe it currently, it is, launch date plus 5 days in terms of its ideas. I think the problem associated with these simulations into communicating is, as you've acknowledged, non-trivial. And certainly my aim initially with regards to the visualization component being something that we could at least start to discuss relates to just getting simulations talking, as you say, in perhaps not even a very meaningful way, but at least a precursory fashion. I think the interesting interaction, and this certainly has come through correspondence with Gerald de Jong in particular, is the idea of the simulation authors sitting down, looking through the XML and actually having meaningful dialogue. I mean, looking at your MicroPond 1 XML, for example, for me, there seem to be a number of components that could easily translate into the Nopal Ape environment. So, I mean, I think the idea is that we put our XML phenotypes online. We then have a good degree of dialogue. We start talking about what space and time and energy and these kind of things actually mean within our specific simulations. And then we try to have some kind of shared overlap. I mean, obviously there's going to be pluses and minuses going in both directions in terms of, what this combination of things will actually produce. But the idea is that you have some starting point to actually have this kind of dialogue, as opposed to just saying this problem seems too complicated to even have a starting point. So looking at it as it is currently, obviously it appears to be almost kind of juvenile in the triviality of the things that are offered. But the view is, for example, I mean, if you look at Gerald's XML phenotype output, it is almost exclusively structural and relates to the interconnections, the vertices of these particular tensegrities. So I think what is interesting is that in having, if you or I or potentially Jeffrey Ventrella or John Klein with Breve or any of the other simulators that come in, Dave Kerr with AI Planet, what have you, they come in and there is this degree of dialogue where, Dave Kerr says to Gerald, well, I can import all your tensegrity vertices, but, I need some more information or less information. And I mean, I think the trick with regards to the XML phenotype as a starting point is not even really to say that this is purely a phenotype, this is purely just a visual representation, but there is potential for simulators to actually have a broader discussion associated with shared genetics, as you say, not just the idea of energy, space and time, but also some degree of purposefulness, maybe direction vectors, these kind of things, and then additional momentum. And what comes from this is the ability for simulators to initially start sharing this interface, but then move towards things like sharing code and all the kind of stuff that people, we've been talking about through Biota since Biota was formed, and I think this is a shared vision through, all artificial life simulation authors. So, I mean, does that make some sense in the context of Biota Eve?
It really does. Actually, that was really helpful, and I agree. Looking at I did look at the XML phenotypes for both the Noble Ape and the Darwin at Home, and yeah, it was very instructive. And I think particularly with these simulations, I mean, often, I find you run a simulation and it's really hard to know what's going on looking at it, and how deep it goes and how long you should wait to expect to see emergent behaviors and so on. So, having the XML phenotypes is a great way to document what's going on. I guess my concern is really about, the potential for what really excites me, which is the EvoGrid sort of, or Biota Eve, I should say, kind of helping our creatures to evolve faster. That's what drew me to it, and that's what I'm still struggling with.
Okay, so to summarize that component, if you imagine that as things are currently, a user downloads a particular artificial life simulation and they run it on their own computer, the other part of the XML phenotype, which actually allows for, genotype and all possible information to be passed through XML, is the ability for simulation authors to create not just a means of communication with other simulations, here being, Noble Ape, Darwin at Home, Breve, AI Planet, Micropond, Nanopond, et al. It's the ability for someone to run a version of Breve and know immediately that there are 5,000 other versions of Breve running, of which 15% are running exactly the same kind of code, and then kind of sharing that power over the internet. So the beauty of the XML phenotype is it's not just about communicating with other kinds of simulations, it's also about communicating within simulations over, in this case, the internet. So I think that's the broader strength in terms of faster, better, just thinking about the way in which simulations are written with the context that it is no longer just an isolated simulation run on a single computer, but it is in fact a kind of broad network of, in one case, the same simulations, in another case, a broader group of simulations that can accept some of the simulations' shared information. And I think that's another powerful thing that really hasn't been described actively through Biota Eve, but certainly I'm thinking about with regards to my own development. And obviously, Gerald's been talking about that kind of idea for a couple of years now as well. So, I mean, does that make sense to you?
I think it does. Are you essentially talking about Biota Eve as being a platform for kind of a distributed simulation?
Well, a bit of both. I mean, I think this is the nature of this kind of project. I mean, the idea initially is that it will be all all the contributing authors' responsibilities to write, obviously initially the file saving and then file reading component. But as this idea becomes spread over the internet, then it becomes, UDP, TCP, IP kind of communication, so XML packets kind of sent between not only, the same simulations run on multiple machines, but also, other simulations that are running. And I think that's where it gets really interesting in terms of how the XML information is used. But, obviously, this is kind of, 10, 15 steps ahead part of the process, but I think it certainly answers your concerns with regards to how this will actually make better simulations in the long run.
Okay, well, that makes sense as a vision. It's really it's helpful for me to sort of understand the level at which biota is now, and you're describing it as almost like first steps.
Exactly.
So that's useful.
And I'm not sure if you heard Gerald's discussion with regards to the EvoGrid in the last Biota Live, but I think his point with regards to the EvoGrid, specifically moving from Biota Eve now to the EvoGrid formerly known as EvoGrid Deep, the ideas within the EvoGrid are not even as strong or well-formed as what we're describing with regards to Biota Eve currently. But, in terms of artificial chemistry moving into artificial life, as that as an abstract idea, what kind of vision do you have associated with the potential for the EvoGrid?
You're talking okay, the EvoGrid. I have to keep reorienting myself. So this is the idea that we would simulate an artificial chemistry in which it would be hoped that life would spontaneously emerge.
I guess that's the broadest possible definition, but if you have your own vision within that is more constrictive or even broader, feel free to throw it into the mix.
Well, to me that it seems like a really interesting exercise. There have been a few things that have kind of stopped me with regards to that. One being that, so as I understand it, part of the goal with the EvoGrid was that we could evolve within a simulation some kind of self-replicating chemicals that we might call life, and that those could be then manufactured in the real world. Or at least that's one vision that I've understood. Does that line up with your understanding?
Well, that's certainly EvoGrid the movie, and okay. I think this is the theme both with regards to actually creating these critters in the real world and also sending them to asteroids on EvoGrid, the movie, the sequel. So, I think they are two combined visions, but obviously as you appreciate with the kind of baby steps nature of these kind of projects, really there's a lot of stuff that needs to go on to move from even chemistry. The idea of artificial chemistry is non-trivial. I found in my bookshelf last night, actually, the MIT Press's Artificial Life Journal, the first one for this year, which was dedicated exclusively to achemistry, and it reminded me of what Gerald Jung had said about the geometries, that the geometries for this kind of process were really critical. So the EvoGrid as it exists now is really Peter Newman running a series of existing atomic and chemical simulations, getting a sense of which of these would be the best base platform to build the EvoGrid from. But, in terms of your own vision, do you think this is the way to start, or do you think there is a better, more a priori way to begin?
So one question I have about this vision is, why attempt to simulate artificial chemistry? What advantage does a simulation of artificial chemistry have over just a big vat of solution in the real world? Because it seems to me that any time you try to simulate something, your simulation is going to be much slower than the thing that you're attempting to simulate in terms of the processes. So, and I just it seems that it took such a long time in such a large body of water for life to emerge on this planet that I'm just kind of skeptical that we're going to, see in the simulation of anything like real chemistry that we would expect to see life emerging.
So there are two parts of this. The first is to do with the actual world, and the second is to do with possible worlds. And I think within a simulation context, there are certain things that can emerge through both of those. I, too, have concerns associated with the idea that what you do is just create, a simulation of the real world and then wait for life to emerge. I think that, as you say, is a very long-term and very problematic a process, which is, almost certain to be, end in brilliant and highly expensive failure. But I think what interests me is this ability, particularly within, the existing methodologies that we have with low-level artificial life simulation, to create possible worlds and then tune the possible world space to be an environment where, the artificial life chemistry will work a little bit better to move towards life. Now, through this process, obviously, you're also almost, forcing the hand of these things to be created. And I think this is the real kind of, methodological difficulty associated with the EvoGrid is there are many shortcuts that could be taken in order to get to, the emergence of life. And I think what interests me with regards to the visions of the EvoGrid series is obviously, I'll be talking to, biology folk and philosophy folk and, computer science folk, a wide variety of people. But this is the most important question. I mean, is it just a matter of, as you say, creating some soup associated with the real world and just waiting? Or are there actually underlying simulation principles that can work a lot better? It was interesting talking to Dick Gordon about this specifically because he portrayed, firstly, that we need to start with the real world, but we need to just improve the simulation, kind of searching almost. So you start with a large body of water and the simulation in part scans through the body of water and finds the areas where it thinks that, there's a higher probability of life to emerge and then, super simulates those areas and potentially darts through the simulation space in this way. I mean, I don't know whether that is particularly convincing, particularly to a skeptical audience, but I think there's potential for a lot of kind of beautiful, simulation methodology to come out of this. I mean, what's your own thinking in this regard?
Well, I think it's a fine enterprise, and I think what you were just talking about was this idea that the simulation becomes a way of searching for the most optimal conditions in which life could arise. Is that basically right?
Well, I think this is one of the many potential visions of the EvoGrid, but I think it addresses the concern that you had in some regard, although it just raises a whole pile of additional concerns.
Yeah, honestly, I mean, I think as far as I'm concerned, it's a little academic for my tastes. That not that there's anything wrong with academics or sort of understanding the historical origin of life. It's just not where my particular interests lie. So I guess my feeling about it is, more power to you. So for those who are involved in it, it seems like if we can understand better how life arose, that's a wonderful thing. But I guess my interest is more in the potential of using the principles of evolution to solve problems. As basically a substitute for intelligent design in problems that we confront. So, and one issue with the kind of emergent life approach is that it seems to me in that case that what you're selecting for is for the ability of these simulated organisms to reproduce. Like that is the fitness function, essentially. That's what determines if they're successful or not, is if they're actually able to make more copies of themselves. And I think in a more abstracted kind of evolutionary simulation, you have more freedom, and you can specify what the criteria are. And so to me, that seems like it has more practical applications. I mean, not that one is necessarily better than another. It's just, again, where my particular interests are.